Hello, my name is Nicholas Zwernik. This is our ME3501 project, Topic01, CO2 Sequestration by Reed Hooby and myself. So what does global warming mean to me? You might be asking yourself that question. Sure, we've all heard that man-made CO2 is causing the world to heat up, but how bad can it really be? Temperature changes have happened in the Earth's past, right? This has happened before. Let's look at a small temperature change of just 4.3 degrees Celsius, worldwide average. What does a change of 4.3 degrees Celsius really look like? Look at Boston. Under a mile of freaking ice and snow, Chicago's buried completely. Way back thousands of years ago, uh, it was 4.3 degrees colder on average over all the entire Earth. And Boston was under a mile of ice. Later, today, temperatures have come up and the Industrial Revolution has happened. We started releasing CO2 in huge numbers, and our temperature range, our whole uh, delta T is climbing readily. By the year 2100, estimates are about 3.5, almost 4 degrees of change if we keep on our current path. 4.3 degree change caused mile-thick glaciers. A 4.3 plus change would cause an equally disastrous change in the opposite direction. So that just makes sense. That's bad. What can we do about this? Human actions are now releasing 4.9 billion metric tons of carbon into the atmosphere from activities such as burning fossil fuels and intensive agricultural practices. But the concentration of carbon dioxide that stays in the atmosphere is only increasing by about half that. And that's because half of the carbon we keep releasing through the atmosphere is currently being taken up by land and seas through a process known as carbon sequestration. So, in essence, whatever consequences you think we're facing from climate change right now, we're only experiencing the consequence of about 50% of that pollution because the natural ecosystems are bailing us out. That's from Amerset Asif Bari, a soil scientist. The single biggest thing we can do as a species is to start supporting nature's side project of stopping us from killing ourselves. This is a massive global undertaking, a huge problem, and it boils down to a pretty simple equation. The sum of all the carbon captured minus the sum of all the carbon released equals the amount of carbon stored in the environment. Photosynthesis is the thing that's capturing the carbon in the air to make plant biomass, and the carbon released is mainly through decomposition of that plant biomass and burning and so forth. There's a lot of sources that release carbon into the atmosphere, including human activity. The problem is our tendency to treat the land like dirt. We have a responsibility to improve the quality of the ground under our feet by improving its carbon content. Now, take a wild guess from these two samples here. Which soil has more carbon? I think it's the one on the right. It should be no surprise that carbon-rich soil is good for the environment. We can improve the ground's carbon content by employing climate-smart land management practices. So what does that look like? Proper land management practices mostly center around preventing deforestation and proper agricultural management, including preventing and mitigating soil degradation, appropriate soil erosion control practices, completely eliminating the burn of crop residue, and instead of burning those crop residues, develop and widespread use of biochar technology, process of turning that biomass into charcoal by heating in an oxygen-poor environment. This carbon-rich biochar could then be used as fertilizer, and proper use of naturally occurring fertilizers, i.e. manure. For more information on land management practices, see reference 2. So how can we raise the percentage of the oceanic carbon sequestration? The answer is seaweed. Seaweed takes carbon directly from the water column to grow. Both wild and farm seaweeds can serve as carbon sinks by removing the carbon from the water column and storing it in their tissues. Wild seaweed has the problem that it can decompose in the water column and thus releasing its stored carbon back into the environment. But farm seaweed removes carbon from the environment when it's harvested and allowed to sink deep into the ocean. So what would that look like? If we could cover 9% of the world's ocean in seaweed farms, we could draw down the equivalent of all the greenhouse gases we put into the atmosphere every year. That would equate to approximately 4.5 times the size of Australia. So that would be a very large stretch of the ocean. Then we could simply cut it off and allow it to drift down into the ocean about a kilometer down into the ocean. That carbon would be completely cut off from the atmospheric system. So as you can see here, the seaweed absorbs the CO2, releases oxygen. We could then take the plant, allow it to float out to sea, and allow it to sink naturally. And that carbon would be completely cut off from the environment. So, in conclusion, there's only two ways that we can really remove CO2 from on a large scale. There's chemical pathways and biological pathways. The chemical pathways would come at a huge upfront cost and would take many decades before those chemical pathways are drawing down even a gigaton of CO2. The biological pathways are an awesome option because the energy source needed to drive them, the sun, is essentially free. We need to make a change here and start helping our planet's effort to clean up our mess. References are as follows. If you'd like more information, I definitely recommend checking them out. Thank you.